Hello, and welcome to our talk, Demystifying eBPF Security, Navigating Risks, Safeguards, and Best Practices. I'm James Callaghan, a principal consultant at ControlPlane, a cloud-native security consultancy. I work as a security architect and have been involved in the past with the creation of several open source threat models, including those for Envoy Gateway and Argo CD. I'm here with my colleague Jack.
Hello, I'm Jack, also for ControlPlane. I'm a senior consultant with a strong focus on engineering and a love for security. I've done threat modeling work in open source in the past. I'm sitting on the in-toto steering committee and I package a few eBPF tools for Nix.
So our talk today is going to be based on an eBPF threat model that was recently commissioned by the eBPF Foundation. The goals of this threat model are ultimately to help large organizations to adopt eBPF tooling safely and securely. We want to explore what an attacker could potentially do with eBPF. We want to detail eBPF safeguards that are in place that will actually reduce these risks. And then we also want to provide recommendations on the secure use of eBPF tooling generally beyond the inbuilt safeguards. A really important thing is that threat modeling is collaborative. We will refer out to some really excellent work in the threat model paper itself. And then also we have relied on input from some true eBPF experts. So thank you to absolutely everyone who has helped us in the creation of this threat model. We're going to be following the show stack 4-question framework when we are doing our threat modeling. First of all, we need to ask, what are we building? Ordinarily, this step would involve going into low-level detail about a system. However, we are considering eBPF generally rather than a specific implementation. Therefore, we've kept the scope extremely high, which we'll see on the next slide. Once we have a scope, we can start catastrophizing and asking the question, what can go wrong? We will use attack trees to enumerate what steps an attacker would have to take in order to achieve a high-level goal, which will ultimately always revolve around compromising confidentiality, integrity, or availability of business data. Once we have done this brainstorming, we can collate the threats into a final set and devise mitigating controls by asking, what can we do about it? As we said before, eBPF helps us here with inherent safeguards that we will discuss, but also we will consider best practices which could apply to eBPF tools or otherwise in order to supplement these inherent controls. The final step considers whether we have done a good job, and this can be answered, for example, by looking at our attack trees, mapping controls, and ensuring that we have full coverage. So here is our scope. In order to derive the most general set of end user recommendations, we will make a few assumptions. First of all, we will have user space workloads running in a multi-tenant platform where different tenants' workloads could possibly be co-located on the same Linux host. We will not make any assumptions, however, about how these workloads are orchestrated. Another assumption we'll make, you can see on the right-hand side, we have a platform team running eBPF programs for observability, networking, and or security reasons. Again, we're going to be very high level and not very specific here. And then finally, we will not make any assumptions about the security context of tenant workloads. So in the worst case, where workloads could run with elevated privileges, for example, malicious tenants could attempt to run eBPF programs that they shouldn't in order to bypass security control. So here is an attack tree example, which Jack is going to walk you through.
We're going to take a look at an attack tree. We're only going to look at one and more specifically just part of an attack tree, just due to the time we have. Important things before we get into it is what is the legend we're using. So we have leaf nodes, we have and nodes in blue, which means we'll need both of the items below, and all nodes in green, so either option works. We're going to go top to bottom from the attacker goal, in this case, unauthorized access to sensitive information. And yeah, we'll go from there. So at the top, we've got the goal, as I just mentioned, and we're going to take the left path. So we're a co-tenant on the machine, and we want to look at files that we shouldn't usually have access to. So in order to do this, we've got a blue node. So we need both of the options below. We are assuming we're an internal platform user, and that could be either of those options below, either an admin or, in this case, I think it's most interesting to look at a tenant that's been given the ability to run eBPF. So that's kind of our actor in this case. And on the other side, we've got the helper function that we plan to use. So this node is an AND, so we'll want both of these paths. In this case, we're going to need certain capabilities. So if we have cap sysadmin, we can use this helper function. And then in kernels 5.8 and onwards, there are more granular capabilities for this. So we could have cat BPF plus cat perf1. So either sets of those capabilities would allow us to use this function. And then on the left, once a user that has access to that file opens the file, we would then get to read what they saw.
Okay, so now we've been through one branch through an attack tree, we can start to think about what controls can prevent some of the bad things that can happen. Now, first of all, we'll go through the inbuilt eBPF controls, the inherent controls, if you will. The first of these is the verifier. So before a program can be attached to an appropriate hook, the eBPF program must pass through the verifier, which carries out a few checks. It confirms that the process loading the eBPF program holds the required privileges. It confirms that the program does not crash or otherwise harm the system. And it confirms that the program always runs to completion and doesn't, for example, just sit in an infinite loop. It does these things and many more, but this is kind of the first safeguard that we'll come across. It's worth saying a little bit more about privileges, because as Jack showed in the attack tree, that attack path could not have been carried out if the tenant could only run a program with cat BPF and cap netadmin, for example. So this is quite a good inherent control that we can build on when we design the kind of least privilege model, which Jack will go into on the next slide. Finally, there's a bunch of these which we'll go through in the paper, but we'll just draw out another one here, which is that warnings are printed to kernel logs if an eBPF program tries to do something particularly nasty, such as writing to memory associated with some arbitrary process. So these are the inbuilt controls, but we also have some recommendations that we make, which Jack will take you through now.
So yeah, this is a non-exhaustive list, but just a couple to give you a taste. We've covered kind of more granular capabilities, but also if you make sure that your processes loading eBPF aren't too exposed, that leaves you less options for attack. We've got separation of duties, so this is recommending that loading eBPF programs is probably a system administrator type action for these multi-tenant machines. And then, as with any program, supply chain kind of best practices are always good. You want to have increased confidence that the program is from the right people, the right vendors. If it's open source, you can take a look at what the program's doing, that kind of stuff. If you're loading your eBPF from a process that you're running in a container, then you've got a nice option for applying signing if you make sure that image is signed. But yeah, Thank you so much for listening.